number 3. To decide which kind of diagram I have to follow, I have to take a central section that is at 2 meter. At 2 meter, this ordinate for 4 meter it is of 20, for 2 meter it is of 10. And if we are going to find out shear force at this section which has been defined as D, which is equal to minus 1.67 minus half into 10 into 2. This gives me minus 1.67. Interesting answer, minus 1.67. Now, if we are going to take a straight line, then what will be this ordinate? If we are taking this as a straight line, then central ordinate is of 41.67 plus 1.67 divided by 2. Repeat this word. It is interesting to note down that one. That is 1.67 plus 41.67 by 2, and this gives me around 41 plus 2 42, that is 43.5 by 2, that is around, let it is of 22 approximately. So this central ordinate, if I will choose as a straight line, then central ordinate is of 22, but our answer is of minus 11.67, minus which is less than approximate of 22. So our diagram, my ordinate is over here. I have to join with this diagram. Try to understand the concept. If I will take a straight line, then ordinate must be of approximately of 22, but my answer is of 11.67. 11.67 is much lesser than 22, so my diagram is follow-up is of like this. So see how that we can find out the nature. If you are unable to do this thing, then what you have to do, you have to take a section XX, you have to convert this ordinate in terms of x, you have to generate the equation, you have to solve this equation at various points, and then you have to join. So it's a lengthy procedure. So why we are not adopting the simple procedure at the section at central point? So this is the simplest procedure, that this kind of curve that we obtained over here. Now if we take the section just right of B over here, then this reaction which also comes into the part. So if I will take shear force at B just right is equal to minus 1.67 minus half into 20 into 4 plus 101.67, and that we achieve as 60 plus sign. So that means at a point load over here, my shear force changes suddenly 60. After that, between this B and C point there is no load, horizontal straight line, and which is obtained directly as 60. Minus sign, this is plus sign. This is my shear force diagram. So now let us be understood the basic concept from this diagram, that reaction directly gives us the value of shear force at over here. When my overhanging beam subjected to uniformly varying load, my shear force changes by parabolic nature of this kind nature. There is an application of point load, shear force changes abruptly. Between 2 point load, if there is no load, shear force variation is given by horizontal straight line. So I wish you will understood this, how to plot shear force diagram. Let us we go for the next one, how to plot the bending moment diagram right now. The beam given is of overhanging beam. $60 kilonewton is the point load acting. 4 meter is the length between two supports. 1 meter is the overhanging projection. This reaction is of 1.67 of downward direction. This is 101.67. This is our baseline, and our intention is to plot the bending moment diagram because of this. So now bending moment at A is equal to, now refer carefully, bending moment at A, there is no any kind of overhanging projection on this side, so only single force is of 1.67. so if we take just section near about the section support A, then only one load 1.67 is acting and the perpendicular distance is 0, so my BM at A is 0. Now intention is to find out bending moment at B is equal to, bending moment at B is equal to find out over here. First one, 1.67 into 4. This creates the moment by the force of 1.67, but it creates, take a section over here, section left, anti-clockwise, hogging nature, negative sign. Once again, next, another force which is of this uniformly varying load. So half into 20 into 4 multiply by, because this uniformly varying load which is equivalent point load is over here, that the figure which has been shown in the PPT, that this is the load, half into 20 into 4, which is acting at the CG. My intention is to take the moment over here, so this is the perpendicular distance and this distance is of 1/3 into 4, so this is 1/3 into 4. Now about the sign convention, this is the section, this is the force, section left, anti-clockwise, hogging nature, negative sign, and you just solve this one and we get the value which is of 60 negative sign kilonewton into meter. So we achieve this value which is of 60. Question may arise, how to, this is the value is 0, how to join these 2 points? It is obvious that when shear force diagram which has been joined over here right now by parabola, in terms of x square nature, then my bending moment diagram, it must be of cubic parabola. The important word, cubic parabola, my equation in terms of x cube. Now this cubic parabola, it may of like this or may of like this. How to join? Let us we adopt the same theory, the theory we adopted for the shear force diagram. Recall what we did in case of shear force diagram. We take a section at the center, we find out the value of shear force at the center, we know the central value. If we take a inclined straight line, the value is lesser, which is of convex type of nature. So now let us be understood over here right now. Take a section at the center. So my figure looks like over here. Downward direction 1.67. This ordinate is of 10 kilonewton per meter. Length is of 2 meter. So bending moment at this section D is equal to minus 1.67 multiplied by 2 minus half into 2 into 10. This is the total load which is acting over here. The distance CG is over here, 1/3 into 2, and we got that is of 1.67 multiplied by 2, which is of, this is of minus 3.5 minus 20 by 3, and we got minus 3.5 minus 6.67, and then we achieve 10.17 minus sign. Minus 10.17, we obtain the value of bending moment at the center. So if we take a inclined straight line nature, then these ordinate must be of 30. 0, 60, central is 30. But we achieve minus 10.67, means much lesser than that. So our diagram, our behavior of bending moment diagram, which is of like this. This is of 10.67 negative sign. So now I wish you have understood the concept how this diagram which has been adopted. Now after this point, at this point C, obviously the diagram bending moment is 0. How it will be behave? It once again behave of like this, parabola, because point load is there, bending moment diagram which is shown by parabolic nature. Is it parabolic nature because there is no load? No, it is obviously a straight line nature. So this is of straight line. Remember our fundamentals. Between 2 point load, if there is no load, the variation of bending moment diagram which has been given by inclined straight line. Or you may take a section at center and you can find out the straight line. And this is of cubic parabola. Ordinate is of 60. So minus sign. So you visualize that the whole beam is subjected to the negative bending moment throughout the beam. I wish you have understood how to plot this diagram, and this diagram is known as bending moment diagram. So if you refer on this PPT, this is the shear force diagram. Variation under the load of UDL is given by parabola, square parabola, and if you refer this bending moment diagram, the variation is given by cubic parabola, and between these two load, between this reaction and the load, there is no load. The variation of bending moment is given by inclined straight line. Now let us proceed with the next problem, and let us be clear much more fundamental with the next problem. Now in this given particular beam, refer carefully, only the two different kinds of the load which has been given to you, that is of uniformly distributed load and the point load. But here the important thing that you have to be noted down, that this is my support A. There will be some overhanging projection on the left side. This is my support B. There is some overhanging projection on the right side. So for both this side, overhanging projection is there. This is to be known as two-way overhanging beam. The given beam, which is of two-way overhanging beam, refer 1.2 meter is the left projection having subjected to 10 kN per meter UDL. Then this is the point load at 1 meter the distance, and for the total 5 meter length, 20 kilonewton per meter uniformly distributed load is acting. Now, step number 1. Before finding out the shear force and bending moment at any section of a given beam, the step number 1 is to find out the support reaction. How to find support reaction? The support reaction, which has been found out by using concept known as equilibrium. Now, at A, the two reactions are developed, RAH and RAV. At B, only single reaction is developed, that is RB. Taking the first equilibrium condition, sigma H is equal to 0, and there is not a single force of horizontal force which is acting on throughout the beam, RAH is equal to 0. Another equilibrium condition, sigma V is equal to 0. The first force, if we take RAV, which is acting upward, so plus RAV. Now this 10 kilonewton per meter which is acting downward, so 10 into 1.2, so minus 10 into 1.2 acting downward. Another force is of 40 kilonewton which is acting downward, so minus 40. Another load which is of 20 kilonewton per meter for the length of 5 meters, so minus 20 into 5, plus RB which is acting upward, plus RB which is equal to 0. So we got RAV plus RB as equal to 152 kilonewton. We have an equation consisting of RAV